Okay, here we go. Lesson 1.4. This is definitely going to be something a little bit new for you, even though the concept of absolute value is not new. So let's just kind of take it step by step and really try to think about what we're going to be doing here. So it says in an absolute value equation, or an absolute value equation, is an equation that contains an absolute value expression. You can solve these types of equations by solving two related linear equations. So let's kind of just refresh our memory here. For instance, let's just say the absolute value of x is equal to 4. So if you recall, absolute value, it's telling us the distance from 0. And we know that the absolute value of any number is given as a positive value because we measure distance as a positive value. It doesn't make sense to say that the distance was -4. You know, that's making the negative sign become a vector, and save that for physics. So what we can say is that in order for the absolute value of x to be equal to 4, then we are pretty sure that x would be equal to 4, right? Because the absolute value of 4 equals 4. Or we know that x could be equal to -4 because the absolute value of -4 is also 4. Okay? So we kind of just, these are two linear expressions, right? X is equal to 4 is a line. That's a, a vertical line. So, you know, we could have that when we talk about these two related linear equations. So when you see them written as an expression, so let me just add 1 to this x and make it an expression in here. Okay. Well, what we're going to be solving then is what's inside this absolute value symbol, because what we know to be true is that x plus 1 as a value has to be equal to 4, or the expression x plus 1 has to be equal to -4. So I know that if you want to be writing this down, you could write it on page 20, maybe towards the top. And then we could solve this to find out what values of x would work, okay? And then we know that it could be true. So let's take a look at a few more things in your core concept. Okay, so in the core concept, one really important thing is number 1. We know that the absolute value of anything has to be greater than or equal to 0. So it can be equal to 0, but it has to be greater than 0, meaning that we would not see an absolute value equation or expression inside the absolute value symbols equal to a -2 or a -5 or a negative anything, because it has to be greater than or equal to 0. We know that when you have the absolute value of -a for number 2, it's equal to the absolute value of +a, right? Because the distance from 0 is the same. A couple other properties that are useful is if you have a times b inside the absolute value symbols, it's equal to the absolute value of a times the absolute value of b. And same for number 4. If it's a quotient, a divided by b, it could be the absolute value of a over the absolute value of b, making sure that b is not equal to 0. So here's kind of what we talked about in that last slide. When you have this expression, right, ax plus b, the absolute value of ax plus b is equal to c. We know that c is greater than or equal to 0, meaning that this c is not a negative number. Then we know that we could either have the inside value be equal to a positive, or the inside value could be equal to a negative. And these are the two linear equations that we would solve, okay? When c is negative, so if c is negative, the absolute value equation has no solution. So we will look at some of those today as well, because we know that absolute value always indicates a number that is not negative because it's indicating the distance from 0. So let's give this a try. So in your book, I know many of you don't have a book, but in example 1, they're showing you a couple different ways to do this. So solving the absolute value of x minus 4 is equal to 6. For A, we will write two related linear equations. So we will take the value inside the absolute value symbols, and we will make that equal to 6, and then we will make an equation equal to negative 6, because we know that it is true that the absolute value of 6 equals 6, and the absolute value of negative 6 equals 6 as well. So that's where we can set these equations equal to the things that would be inside the absolute value symbol. So you solve this. We just add 4 to both sides and you get x is 10, or add 4 over here and you get x is negative 2. And then if, because our solutions, we have 2 of them, and you have a number line, you can graph the solutions. And here's some things that we find. So in this case, it's like we have a minimum of negative 2 and a maximum of 10. The mean, okay, or the average, or the halfway point, so to speak, is 4. And how far away from 4 are they? 6. All right. So look at B. B gives us this expression. The absolute value of 3x plus 1 is equal to negative 5. The absolute value of an expression has to be greater than or equal to 0. And since this C is equal to negative 5 right here, this equation has no solution. So we may encounter those. Let's try some from our student journal on page 21. Well, 20 and 21. So we'll start with 1. So in this case, we have the absolute value of 3x plus 12 is equal to 0. Because 0 doesn't have, a negative value, we really only have one linear equation. This is the one exception, is that when it is equal to 0, you have one equation to solve. So we just have to solve this 3x plus 12 is equal to 0, because it doesn't make sense to say, or 3x plus 12 is equal to negative 0. So we just solve the two-step equation. I'm going to continue over here. So I'll get 3x is equal to this negative 12. And when I divide by 3, I get x is equal to a negative 4. So the only value that we have is, and I'll try to do my best to get it on that negative 4, but pretend like it's exactly on the negative 4. Okay? So the only reason why we didn't have another equation to solve is it does not make sense to have a negative 0. All right, let's try 2. Okay, so we are wanting to know what values will make this true. So we know that inside the absolute value symbols, we could have an 8 or we could have a negative 8. So we could write those two equations. Y plus 2 is equal to 8, or y plus 2 is equal to negative 8. And the reason that we do this is because what goes inside right here could be positive, or technically it could be negative, right? And they both have an absolute value of a positive 8. So we need to set that expression equal to the 8 or to the negative 8 and solve for y. So we will we will subtract. In fact, I'm going to get rid of this little line here. We will subtract 2 from both sides, so we'll have y is equal to 6, or we have y is equal to a negative 10. And that's not a 10. Oh, Lordy. Okay. Y is equal to negative 10. There we go. So we could graph negative 10, and we could graph 6. Oops. It won't let me make the dot. Heck, why did it let me do it on the other one? I don't know. Oh, brother. Okay, let me just make the dot at 6. Okay. All right, there we go. So that's how we would graph it. All right, those are the two values of y plus 2 that would make this statement true. All right, next up, All right, sometimes in solving these, we have to do a little bit more work, right? The main thing is that we get the absolute value part of the equation by itself. So when we look at this, solving the absolute value of 3x plus 9 minus 10, we have to get rid of this first before we can go into that step where we write the two linear equations. So we know that we can write the equation, and if we add 10 to both sides, right here and right here, okay, this 10 would cancel out, and we're left with this. All right, now we have it in the shape of the way we were doing it in the first example. So we know that the expression 3x plus 9 could be equal to 6, or it could be equal to negative 6, because if we substituted in a 6 or a negative 6 inside the absolute value symbols, the absolute value is 6. So subtract 9 from both sides, okay, and we'll get 3x is equal to negative 3. Divide by 3, and we'll get x is equal to negative 1. Or you do the same process over here, and then divide by 3, and get x is equal to negative 5. So the solutions are x is equal to negative 1 and x is equal to negative 5, and that would give us a true absolute value that is equal to 6. So let's give number 3 a try. Now this is on page 21. So when we look at the negative 4 times the absolute value symbol, the way we undo this multiplication right here is to divide on both sides. So we're going to divide both sides by a negative 4. Okay, that'll cancel the negative 4 here. So our goal is to get this absolute value expression by itself. If I divide 14 by negative 4, I get a negative 3.5. And this is where you should start thinking, that cannot be done, because whatever I substitute in for 7 minus 6k as an absolute value symbol, when I do the absolute value, when I evaluate the absolute value of that number, it cannot be negative. It cannot be less than 0. So this is a classic example of a no solution because of this negative value here, okay? So notice at first it wasn't obvious because it was a positive 14, but after we started solving it, a positive divided by a negative is a negative, therefore no solution. All right, number 5. So we want to get the 2x plus 5 absolute value thing by itself. So we're going to start by subtracting 10. All right, so then I have 3 times the 2x plus 5, close absolute value symbols. The 10s cancel, so 37 minus 10 is 27. I can undo this multiplication with division, dividing by 3 on both sides. So I will get the absolute value of 2x plus 5 is equal to 9. So I can write my two linear equations as inside the 2x plus 5 would be equal to 9, or the 2x plus 5 would be equal to a negative 9. So let's just solve them. So we get 2x is equal to 4, divide by 2, and we have x is equal to 2, okay, subtract 5 on both sides. 2x is equal to a negative 14, divide by 2, divide by 2, or x is equal to a negative 7. So we can graph those. We have a minimum value of negative 7. Let me see this. Let me see if I do, watch this, negative 7 and 2. There we go. So we can put those two dots on the number line. All right, so one thing we're going to try to do now is write an absolute value equation. So in a cheerleading competition, the minimum length of a routine is 4 minutes, the maximum length is 5 minutes, and we're going to write the absolute value equation that represents the minimum and maximum lengths. So one part you may want to write down somewhere off to the side is this part right here, okay? So we kind of have each position or each part of this absolute value equation has a special position. So the x minus, and then the number that goes behind that is the halfway point between the two numbers. How do we get the halfway point? Well, we could take 4 plus 5 and divide by 2. So 9 divided by 2 is this 4.5. So 4 plus 5 divided by 2 gives us the halfway point, okay? Then what is the distance from the halfway point to the minimum and the maximum? So you could count them. So if you want to use a number line, this is a great strategy for showing your work. Or you could just, count up in your head or do it that way. And then, so you would get your equation like this. You could try it out. You could say like, okay, if x is equal to 4, which is the minimum, is 4 minus 4.5 equal to an absolute value of 0.5, or is 5 minus 4.5 equal to an absolute value of 0.5? And it is. So let's try one. This one is not in your student journal. So maybe this actually comes from your textbook on page 79. You can find it in the online version of the textbook. Maybe find some extra space on page 20 or at the bottom of page 21 to kind of write this down. So we're two pieces of information that we're given in this problem is that we have a minimum, and that's equal to 16, and we have a maximum, and that's equal to 32. So these are like the solutions of the variable x, right? So if we were to graph it on a number line, and I'm not using the true, I'm just going to eye it up here. I'm going to put them far apart, and I'm going to say we need to know this halfway point, right? So one way to get the halfway point is to average them together. So 16 plus 32, and then divide by 2. So I'm finding that the halfway point is 24. So you can mark that here. 24 plays a really important part in writing this absolute value equation, because our absolute value equation will look like this. We will have x minus, and then we have our halfway point here. All right, and then that's going to be equal to, and this is the distance from the halfway point. All right, so we start this out. We have x minus, and we have a 24, okay? So keep in mind, because 24 was positive, this expression does remain x minus 24. If there's ever a chance that your halfway point, because we have seen some expressions inside with addition, that would come from a negative halfway point. So think about that. Okay. And then that's equal to, now we need to calculate the distance from here to here and the distance from here to here, and it should be the same. So from 24 to 32 is 8, and from 16 to 24 is also 8. So 8 becomes that distance from halfway, and now we've written the actual problem. So if we wanted to solve it, we would say, okay, so I would have to take, substitute in 16 as my minimum. So 16 minus 24 should give me a value of negative 8, and the absolute value of negative 8 equals 8, so that checks. And 32 minus 24 should give me a value of positive 8, which the absolute value is also 8. So you're going to be asked to write some of these absolute value equations from a minimum and a maximum. So you may want to copy this down. And that concludes our notes for the day.